Hello students, here is Divya Singh, Assistant Professor, School of Computer Applications in PPT University. So now in lecture 15 we discuss our topics that are e-commerce, information distribution and messaging, in which we discuss www server, what is HTTP, and web server implementations. Now see our first topic, that is World Wide Web server. The concept of the World Wide Web server was born out of an experimental system developed at CERN, that is European Laboratory of Particle Physics, with the objective of enabling document sharing among scientists in 1989. Next, a prototype system offering the ability to interlink multimedia documents distributed over the network through the concept of hyperlinks was developed at CERN. The developed system offered a intuitive and logical interface that makes it easier to browse textual, graphical, audio, and video information integrated on the same screen. Next, the original architecture proposed by Tim Berners-Lee consisted of documents stored and managed on server machines and client processes running on distant or even the same machine. Next, the server software was envisaged by envisaged to be a process that receives requests from the client process and replies to them by delivering appropriate documents. In the proposed system, the client and server processes run on machines connected on the same network. Next, the architecture consists of two buildings blocks, the server and the client processes communicating on the same network. Here is the architecture of the World Wide Web, that is B1, B2, B3 and B4 denote web browsers, and there is a web server, and here is also one web server who are connected with the internet, and through the internet the web browsers are connected, and the data is extracted from the web servers. Next, the World Wide Web became extremely popular as the client programs or browsers available offered an easy to use graphical user interface and the ability to point and click in order to access any hyperlinked information. Next, also all the software, that is the server as well as the browser, were available freely over the network. The server, as described in the original proposal, accepts browser request and manages the delivery of documents to the browser. The documents contain hyperlinks, rich text, and multimedia information. Next, the hypertext markup language, that is HTML, described in subsequent chapters, is used for constructing these documents. The request reply paradigm between the browser and the server follows a standard protocol called Hypertext Transfer Protocol, that is HTTP. In the World Wide Web, unique uniform resource locator, that is URL, defines each published document. Next, a URL consists of the three components, that is the first component prefixed and separated by double slash describes the protocol server for the web. It is HTTP. The second component, the text is starting after double slash and ending with the single slash or end of string, describes the domain name of the server. The third component, beginning with the finishing with the end of string or describes the document name at the server. Next, the web server waits for client connections and request at the port 80 as a standard convention. In some cases, the web server may be listening for browser request at port other than 80. In that case, the port number is specified as the last component separated by colon. Next, in some cases, the URL may not contain the name of a specific document and thus may have only the first two components specified. In such a case, the web server running at the specified domain name serves the default or home document. Next, now see what is HTTP. Hypertext Transfer Protocol is a set of rules that World Wide Web clients and servers use to communicate over the network. It is a connectionless protocol, meaning that browser and servers do not establish a permanent connection. A client opens a connection and submits a request message to a server. The server, on receiving a message, processes and responds to it and closes the connection. Next, it is also a stateless protocol, implying that the server does not maintain any information on the state of the process. Thus, the server treats each request or message independent of any previous request or messages. The protocol is based on the request or response model. Next, the client, usually a web browser, submits a request to a web server. The server reads the incoming protocol packets, processes it, and sends the response. The content type is built as part of the protocol's response packets. Next, the browser has to be aware of the type of multimedia content delivered to it as a response. The content types used in the protocol are a subset of the standard MIME type. As stated earlier, the browser connects to the server machine specified by domain name IP address at the specified or standard port. Next, now see the typical interaction in an HTTP sessions. The interaction is between browser and web server. First, the browser establish TCP connection from the web server. Then for the connection, the browser sends request. Next, then sends the request headers. In reply to the browser, the web server sends response code, sorry, sends response header. Next, sends requested data and then closes TCP connections. This is typical interaction in an HTTP sessions. Next, on making a successful connection, the browser submits an HTTP request. A typical HTTP session between the clients and server is depicted in the figure above. See again the figure above, how the browser and web server is communicating. Next, the session consists of two phases. The first phase consists of the client's request submission, while the second phase consists of the server response. The client submission depicted in three steps involves opening a connection, sending the request, and header information. Next. Now the first step is HTTP packets can be transmitted only after the client has established a connection with the server. In this step, the browser parses the URL for identifying the domain name. It uses the services of domain name servers, that is DNS, to resolve the name into an IP address. Using these services offered by the TCP layer, it opens a connection to the IP address at a standard web or URL specified port. On the successful opening of a connection, the browser starts the HTTP session. Next. Now the step 2, the browser submits HTTP packets containing the request command to the connected server. The common HTTP request commands are get, post, and head. The request in HTTP is made up of three components, that is, the command method resource identifier, command method resource identifier, and the protocol version number. An example of the get command is as follows: get slash index dot html http 1.0. Next, in step 3, in this step, the browser submit the header information to the server. The header information includes the browser identity, its capability to handle various types of content, and the referring URL. Next, in step 4, on receiving the client request, the header information, the server processes the request and sends the response to the client. If the request was processed and can be delivered, the server sends an OK response. Next, step 5. Prior to sending the request data, the server sends information about the data, such as the type of content and length of content, as well as information about the server itself as a part of the response phase. Next, in this step 6, the server, after sending the last response header information, sends a blank line to indicate the completion of header portion, the response, and to mark the beginning of the response data. The server sends the response data to the browser in the format indicated in the content type response header. Next, in step 7, the web server on completing the data transmission is done with responding to the client request. At this stage, it would ordinarily close the TCP connections. Next. Now, what is web server implementations? There are several implementations of web servers on the internet. The original implementation done by Tim Berners-Lee's team came to be known as the CERN implementation. Next, the CERN implementation of web server CERN HTTPD was maintained and supported for full features up till 1996. The CERN version has also been known as the World Wide Web Consortium, that is W3C. HTTPD, with the release of the Jigsaw web server by W3C and CERN HTTPD, is no longer supported. Next, the W3C Jigsaw web server is also a public domain open source project of W3C. It supports the full version of HTTP 1.1 with advanced features and is implemented in Java, unlike the CERN HTTPD that was implemented in C and supported HTTP 1.0 protocols. Next, the other public domain implementations was by Rob McCool's team at the National Center for Supercomputing Applications, that is NCSA, and was widely deployed in a short period of time. The server was a public domain open source software and was supported and enhanced up till 1994 at the NCSA University of Illinois at Urbana campaign. That is next. The most commercial implementation of web servers have been based on one of these two architectures. First is Netscape Web Server, and another is NCSA HTTPD server. The Netscape Web Server is based on the NCSA HTTPD architecture, and NCSA HTTPD server support and enhancement stalled in mid 1994 with the departure of Rob McCool. Next, the feature-rich publicity available open source NCSA HTTPD still remains a popular web server deployed on the internet. Many a web server administrator and developer started enhancing the program code to keep pace with emerging features and bug fixes. Next, in other words, the development and maintenance was still taking place, but without a common platform for sharing ideas, solutions, and the distribution of the enhanced codes. Next, the Apache development process is a collaborative software development effort. It is managed by group of volunteers around the world connected through the internet. The team uses the internet and the web for communicating, planning, developing, bug fixing, reporting, and documenting the web server. Next, as a result of the collaborative effort, the group has managed to create a robust commercial grade trendsetter and open source implementation of an HTTPD web server. Next, today web server provides the following four major functions. The functions are serving static web pages, serving web pages generated by running gateway programs, controlling access to the server. Next is logging server access and error statistics. Next, now see NCSA web server. The NCSA web was the most deployed web server till the emergence of the Apache server based upon the NCSA HTTPD version 1.3. The NCSA server was ported and made available on a variety of Unix versions, including Linux, HPUX, IRIX, IBM AIX, OSF by one, Solaris, Sun OS, Ultrix, and SCO Unix. Next, the HTTPD server configure file, that is HTTPD conf, controls the server configuration through a slew of directives. The configurable parameters include the IP address, port number, the number of children the server will launch at one time, maximum number of children processes it will have at any time, support for keep alive request by client, timeout period for the keep alive request, and the login related options. Next, log files are stored in the directly logs directory as per the name specified in the HTTPD conf. The server is capable of logging documents, transfer errors, accessing agents, and referrers related informations. Next, the specified value of log options determines the number of files in which all the four activities are logged. The value of separate implies all four activities are logged in four separate log files. The value of combined implies that the refers and agent's information is merged with the transfer log file. Next, the access.conf file manages the access control. The file contains directives to control access to branches of the document subtree. It also allows setting up controls over the types of request and transfers. It can also set up user or password based authentication by adding the configuration directives in the access.conf. Next, the third configuration file maintains the server resources map in srm.conf using the mapping options available in the file. One can set the directory that will be treated as the root of the documents served. Next, now is Apache Web Server. The Apache Software Foundation distributes the web server under a public domain software license policy. It can be freely downloaded and installed from the Apache website. Next, once the binary version has been compiled and created or downloaded, the installation process requires customizing configuration files for the server. The Apache server configuration directives resides in three main configuration files, that is the installation process setup, the environment to run the HTTPD from the default directory defined by the server routes. The configuration files are located in the conf subdirectory and are called srm.conf, access.conf, and httpd.conf. Next, the conf directory also contains sample configuration files named srm.conf dist access.conf dist and httpd conf dist. These files can be occupied and added to the standard names, that is, without the suffix dist, and edited to provide custom values for the directives. Next, the sample files have self-explanatory comments for each of the directives, but care should be taken to send the parameter value after a thorough reading and understanding of the purpose of each directive. Inappropriate or erroneous setting of values for directives may lead to misconfiguration of the server. Next, the configuration errors may cause the server not to function, or worse still, may lead to security gaps. The conf directory also contains a mime.type file for defining the various data types and subtypes. Next. Now, thank you for listening.